Welcome to Huberman Lab Essentials, where we revisit past episodes for the most potent and actionable science-based tools for mental health, physical health, and performance. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. Today, we're going to talk about an extremely important topic that's central to our daily life, and that's motivation. We're going to talk about pleasure and reward. What underlies our sense of pleasure or reward? We're going to talk about addictions. As well, we're going to talk about the neurochemistry of drive and mindset. But for now, let's just talk about the neuroscience of motivation and reward, of pleasure and pain, because those are central to what we think of as emotions, whether or not we feel good, whether or not we feel we're on track in life, whether or not we feel we're falling behind. So motivation is fundamental to our daily life. It's what allows us to get out of bed in the morning. It's what allows us to pursue long-term goals or short-term goals. Motivation and the chemistry of motivation is tightly wound in with the neurochemistry of movement. In fact, the same single molecule, dopamine, is responsible for our sense of motivation and for movement. It's a fascinating molecule, and it lies at the center of so many great things in life. And it lies at the center of so many terrible aspects of life, namely addiction and certain forms of mental disease. So if ever there was a double-edged blade in the world of neuroscience, it's dopamine. There's a fundamental relationship between dopamine released in your brain and your desire to exert effort. And you can actually control the schedule of dopamine release, but it requires the appropriate knowledge. This is one of those cases where understanding the way the dopamine system works will allow you to leverage it to your benefit. Let's get a few basic facts on the table. Dopamine was discovered in the late 1950s, and it was discovered as the precursor, meaning the thing from which epinephrine or adrenaline is made. Epinephrine is the same thing as adrenaline, except in the brain we call it epinephrine. Epinephrine allows us to get into action. It stimulates changes in the blood vessels, in the heart, in the organs and tissues of the body that bias us for movement. Dopamine was initially thought to be just the building block for epinephrine. However, dopamine does a lot of things on its own. It's not always converted to epinephrine. Dopamine is released from several sites in the brain and body, but perhaps the most important one for today's discussion about motivation and reward is something that's sometimes just called the reward pathway. For the aficionados, it's sometimes called the mesolimbic reward pathway, but it's fundamentally important to your desire to engage in action, and it's fundamentally important for people getting addicted to substances or behaviors. So how does this work? Well, you've got a structure in the deep part of your brain called the VTA. The VTA, or ventral tegmental area, contains neurons that send what we call axons, little wires that spit out dopamine at a different structure called the nucleus accumbens. And those two structures, VTA and nucleus accumbens, form really the core machinery of the reward pathway and the pathway that controls your motivation for anything. You can think of them like an accelerator. They bias you for action. However, within the reward pathway, there's also a brake. The brake or restriction on that dopamine, which controls when it's released and how much it's released, is the prefrontal cortex. The prefrontal cortex is the neural real estate right behind your forehead. You hear about it for decision-making, executive function, for planning, etc. And indeed, it's responsible for a lot of those. It's this really unique real estate that we were all endowed with as humans. Other animals don't have much of it. We have a lot of it. And that prefrontal cortex acts as a brake on the dopamine system. And that brings us to the important feature of motivation, which is that motivation is a two-part process, which is about balancing pleasure and pain. So when you're just sitting around, not doing much of anything, this reward pathway is releasing dopamine at a rate of about 3 or 4 times per second. It's kind of firing at a low level. If suddenly you get excited about something, you anticipate something, not receive an award, but you get excited in an anticipatory way, then the rate of firing, the rate of activity in this reward pathway suddenly increases to like 30 or 40 times. And it has the effect of creating a sense of action or desire to move in the direction of the thing that you're craving. In fact, it's fair to say that dopamine is responsible for wanting and for craving. And that's distinctly different from the way that you hear it talked about normally, which is that it's involved in pleasure. So yes, dopamine is released in response to sex. It's released in response to food. It's released in response to a lot of things, but it's mostly released in anticipation and craving for a particular thing. It has the effect of narrowing our focus for the thing that we crave. And that thing could be as simple as a cup of coffee. It could be as important as a big board meeting. It could be a big final exam. It could be the person that we're excited to meet or see. Dopamine doesn't care about what you're craving. It just releases at a particular rate. If we just take a step back and we look at the scientific data on how much the dopamine firing increases in response to different things, you get a pretty interesting window into how your brain works and why you might be motivated or not motivated. Let's say you're hungry, or you're looking forward to a cup of coffee, or you're going to see your partner. Well, your dopamine neurons are firing at a low rate until you start thinking about the thing that you want or the thing that you're looking forward to. When you eat that food, the amount of dopamine that's released in this reward pathway goes up about 50% above baseline. Sex, which is fundamental to our species' continuation and reproduction, sex does release dopamine, and it increases dopamine levels about 100%, so it basically doubles them. Nicotine increases the amount of dopamine about 150% above baseline. Cocaine and amphetamine increase the amount of dopamine that's released 1,000-fold within about 10 seconds of consuming the drug. However, just thinking about food, about sex, about nicotine, if you like nicotine, or cocaine or amphetamine, can increase the amount of dopamine that's released to the same degree as actually consuming the drug. Now, it depends. In some cases, for instance, the cocaine user, the addict that wants cocaine, can't just think about cocaine and increase the amount of that's released about 1,000-fold. It's actually much lower, but it's just enough to put them on the motivation track for it to crave that particular thing. Now, there are reasons why you would have brain circuitry like this. I mean, brain circuitry like this didn't evolve to get you addicted. Brain circuitry like this evolved in order to motivate behaviors toward particular goals. Water when you're thirsty, sex in order to reproduce. These things and these brain areas and neurons were part of the evolutionary history that led to the continuation of our species. Things like cocaine and amphetamine are disastrous for most people because they release so much dopamine and they create these closed loops where people then only crave the particular thing, cocaine and amphetamine, that leads to those massive amounts of dopamine release. Most things don't release that level of dopamine. Now, nowadays, there's a ton of interest in social media and in video games. And there have been some measurements of the amount of dopamine released. Video games, especially video games that have a very high update speed, where there's novel territory all the time, novelty is a big stimulus of dopamine. Those can release dopamine somewhere between nicotine and cocaine. So very high levels of dopamine release. Social media is an interesting one because the amount of dopamine that's released in response to logging onto social media initially could be quite high, but it seems likely that there's a taper in the amount of dopamine, and yet people still get addicted. So why? Why is it that we can get addicted to things that fail to elicit the same massive amount of pleasure that they initially did? Being addicted to something isn't just about the fact that it feels so good that you want to do it over and over again. And that's because of this pleasure-pain balance that underlies motivation. So let's look a little bit closer at the pleasure-pain balance, because therein lies the tools for you to be able to control motivation toward healthy things and avoid motivated behaviors towards things that are destructive for you. There are a lot of reasons why people try novel behaviors, whether or not those are drugs or whether or not those are adventure, thrill-seeking things, or, they take a new class. As you'll notice, I'm not placing any judgment or value on these different behaviors. Although I think it's fair to point out that for most people, addictive drugs like cocaine and amphetamine are very destructive. Actually, we know that about 15 to 20% of people have a genetic bias towards addiction that, you sometimes hear that the first time that you use a drug, you can become addicted to it. That's actually not been shown to be true for most things and most people, but for some people that actually is true. But in any case, the way that addiction works and the way that motivation works generally in the non-addictive setting is that when you anticipate something, a little bit of dopamine is released. And then when you reach that thing, you engage in that thing, the amount of dopamine goes up even further. But as you repeatedly pursue a behavior and you repeatedly engage with a particular thing, let's say you love running or you love chocolate. As you eat a piece of chocolate, believe it or not, it tastes good. And then there's a shift away from activation of dopamine. And there are other chemicals that are released that trigger a low-level sense of pain. Now, you might not feel it as physical pain, but the craving that you feel is both one part dopamine and one part the mirror image of dopamine, which is the pain or the craving for yet another piece of chocolate. And this is a very important and subtle feature of the dopamine system that's not often discussed. People always talk about just as pleasure. You love social media, so it gives you dopamine, and so you engage in that. You like chocolate, it releases dopamine, so you do that. But for every bit of dopamine that's released, there's another circuit in the brain that creates, you can think of it as kind of like a downward deflection in pleasure. So you engage in something you really want, and there's an increase in pleasure. And then there's without you doing anything, there's a mirror image of that, which is a downward deflection in pleasure, which we're calling pain. So for every bit of pleasure, there is a mirror image experience of pain, and they overlap in time very closely. So it's sometimes hard to sense this, but try it. The next time you eat something really delicious, you'll take a bite. It tastes delicious. And part of the experience is to want more of that thing. This is true for any pleasureful experience. Now, the diabolical part about dopamine is that because it didn't evolve in order to get you to indulge in more and more and more of something, what happens is that initially you experience an increase in pleasure, and you also experience this increase in pain shortly after or woven in with the pleasure that makes you want more of that thing. But with each subsequent time that you encounter that thing, the experience of dopamine release and pleasure is diminished a little bit. And the diabolical thing is that the pain response is increased a little bit. And this is best observed in the context of drug-seeking behavior. The first time someone decides to take cocaine or amphetamine, they will experience a huge dopamine release and they will feel likely very good. However, the next time they take it, it won't feel quite as good, and it won't feel even as good the third time or the next time. But the amount of pain, the amount of craving that they experience for the drug will increase over time. So much of our pursuit of pleasure is simply to reduce the pain of craving. So the next time you experience something you really like, I don't want to take you out of that experience, but it's really important that you notice this, that if there's something you really enjoy, part of that enjoyment is about the anticipation and wanting of more of that thing. And that's the pain system in action. And so we can distinguish between dopamine, which is really about pleasure, and dopamine, which is really about motivation to pursue more in order to relieve or exclude future pain. Let me repeat that. Dopamine isn't as much about pleasure as much as it is about motivation and desire to pursue more in order to reduce the amount of pain. And we are now talking about pain as a psychological pain and a craving, although people that miss a lover very badly, or that really crave a food very badly, or that are addicted to a drug and can't access it, will experience that as a physical craving and a mental craving. The body and brain are linked in this way. It's almost, they'll describe it as painful. They yearn for it. And I think the word yearning is one that's very valuable in this context, because yearning seems to include a whole body experience more than just wanting, which could just be up in the mind. So your desire for something is proportional to how pleasureful it is to indulge in that thing, but also how much pain you experience when you don't have it. And you can now start to let your mind wander into all sorts of examples of addictions or things that you happen to like. I'll use the example that I sometimes use on here, which is my love of croissants. The taste of that croissant makes me want to eat more croissants. Now, eventually blood sugar goes up, satiety is reached, etc. What happens then? What is satisfaction and satiety about? Well, that's a separate neuromodulator. That's about the neuromodulator serotonin. It's about oxytocin. It's about a hormone system that involves something called prolactin. So we're going to talk about all of those in the book, The Molecule of More, wonderful book. Those were described as the here and now molecules, the ones that allow you to experience your sensations and pleasure in the present and for which the brain stops projecting into the future. So now let's talk about craving and these so-called here and now molecules and how those engage in a kind of push-pull balance that will allow you to not just feel more motivated, but also to enjoy the things in life that you are pursuing to a much greater degree. We have neurons in an area of our brain called the raphe, R-A-P-H-E. The raphe releases serotonin at different places in the brain. Serotonin is the molecule of bliss and contentment for what you already have. I've talked before about exteroception. Exteroception is a focus on the outside world, everything beyond the confines of your skin. I've also talked about interoception, a focus on things that are happening internally within the confines of your skin. Dopamine and serotonin can be thought of as related to exteroception. Dopamine makes us focused on things outside us that are beyond what we call our personal space, where we actually have to move and take action in order to achieve things. And serotonin in general has to do with the things that are in our immediate here and now, hence the description of these as the here and now molecules. So it's interesting to point out that the body and the brain can direct its attention towards things outside us or inside us or split our attention between those. Just understand that dopamine biases us toward thinking about what we don't have, whereas serotonin and some of the related molecules like the endocannabinoids, if you picked up on the word cannabinoid, yes, it's like cannabis because cannabis attaches to endocannabinoid receptors, and the endocannabinoids are receptors and chemicals that the cannabinoids that you naturally make that are involved in things like forgetting. But you make these molecules that bind to these receptors that make you feel kind of blissed out and content in the present. So you got these two systems. They're kind of like a push-pull. And if you were to say, do the, in the book, Wherever You Go, There You Are, Jon Kabat-Zinn talks about this meditation practice that's different than most meditation practices, where you eat one almond and you focus all of your attention on the almond, the taste of the almond, the texture of the almond. That's really a mindfulness practice that's geared towards trying to take a behavior which is normally about pursuit. Normally feeding is we engage in feeding because of dopamine. We pursue more of a food because of that pleasure-pain relationship I talked about before. The focus on the one almond or becoming very present in any behavior that normally would be a kind of exteroceptive pursuit behavior and bring it into the here and now. That's a mental trick or a mental task that the mindfulness community has really embraced in order to try and create increased pleasure for what you already have. It's really trying to accomplish a shift from dopamine being released to serotonin and the cannabinoid system being involved in that behavior. Dopamine has the quality of making people kind of rabidly in pursuit of things. Drugs like marijuana, the opioids, anything that really hits the serotonin system hard tend to make people rather lethargic and content to stay exactly where they are. They don't want to pursue much at all. So you've got these molecules like dopamine that make you focused on the things you want and the things you crave. And then you've got the molecules that make you content with what you have. So the most important thing, perhaps, in creating a healthy emotional landscape is to have a balance between these two neuromodulator systems. So at about this point in the podcast, I'm guessing that some of you are thinking, okay, great. I want more dopamine. I want to be more motivated. I don't want to procrastinate as much. And I want to be able to experience life. I want these here and now molecules to be released as well. Well, there is a way to do that, but you have to understand the source of procrastination is not one thing. There are basically two kinds of procrastinators, or so says the research. The first kind are people that actually really enjoy the stress of the impending deadline. It's the only way they can get into action. There are other procrastinators for which they simply are not releasing enough dopamine. For those people, there are a variety of things that can increase dopamine. I do suggest you talk to a psychiatrist or doctor. I've talked about mucunapurines, which is 99.9% L-DOPA, the precursor to dopamine. There are antidepressants like Wellbutrin. Bupropion is the other name for it, which increase dopamine and epinephrine. However, if you think back to our earlier discussion about dopamine, if it's very high, creates a sense of pleasure and the desire for more. So you can also become a person for which enough is never enough. The only thing that dopamine really wants is more of the thing that releases dopamine. And so one of the things that you can do in order to generally just be a happier person, especially if you're a person in pursuit of long-term goals of any kind, is the longer that you can extend that positive phase of the dopamine release, and the more that you can blunt the pain response to that, the better. And you can actually do this cognitively. I used to joke with my lab that when we'd publish a paper, I would get really excited, but I wouldn't allow myself to get too excited. What I wanted to do instead, and what I've still tried to do, is try and extend the arc of that positive experience as long as I possibly can, simply by thinking back like, oh, that was really cool. I really enjoyed doing that work. I really enjoyed the discovery. I really enjoyed doing that with the people that I was working with at the time. What a pleasure that was. So you can extend pleasure without having to engage in the behavior over and over. That's extending the arc of that dopamine release. As well, it offsets some of the pain of not having that experience occur over and over and over again. Now, for the high performers out there, you're probably familiar with this. Many people who have a big achievement, their first thoughts are, well, now what? What am I going to do next? How am I ever going to exceed that? And indeed, many people who are very high on this kind of dopamine sensation and novelty seeking scale are prone to addiction. They're prone to the rabid pursuit of external goals, of exteroception, to the neglect of these internal mechanisms that allow them to feel calm and happy. So for people that are very driven, very motivated, adopting a practice of being able to engage in the here and now, the sort of almond type practices we talked about earlier, of learning how to achieve a really good night's sleep on a regular basis through tools and mechanisms I talked about in previous podcasts, gives us sort of balance to the pleasure seeking and offsetting of pain and the pleasure in the here and now. So pleasure is really two things. It's a joy in pursuit, but it's also the joy in what you have. The cool thing is you can actually regulate this whole system in a way that will steer you or lean you towards more positive anticipation of things in life and less disappointment. It's simply a matter of adjusting what we call the dopamine schedule. In order to understand how to control the dopamine system, how to leverage it for a better life, you need to understand the results of a very important experiment. This experiment was able to separate pleasure from motivation. It's a very simple, but like many simple experiments, a very elegant experiment. What they did, and this has now been done in animals and in humans, they offered rats food. It was a food that they particularly liked. And the animals would lever press for a pellet of food, kind of classic experiment. They'd eat the food, and they presumably liked the food because they were motivated to press the lever and eat it. Great. They took other rats. They eliminated the dopamine neurons. You can do this by injection of a neurotoxin that destroys these neurons. So they actually had no dopamine in their brain. They have no ability to release dopamine. And they gave them a lever. The rats would sit there and they'd hit the lever and they'd eat the food. They're still enjoyed the food. So you say, well, okay, so dopamine isn't involved in motivation and it isn't involved in pleasure. No, it absolutely is. They could still enjoy the food, but if they moved the rat literally one body length away from the lever, what they found was the animals that had dopamine would move over to the lever, press it, and eat. And the rats that did not have dopamine available to them wouldn't even move one body length, one rat length to the lever in order to press it and get the food. Dopamine, therefore, is not about the ability to experience pleasure. It is about motivation for pleasure. And so many of you are probably thinking, wow, I'm not a very motivated person. Like you talked about the one kind of procrastination earlier. What about when I just feel kind of meh about life? Now, for some of you, there may be a real clinical depression and you should talk to a professional. There are very good prescription drugs that can really help people. There's also great non-drug treatments of psychotherapy and other treatments that are being developed in addition to psychotherapy and the various kinds of psychoanalysis, et cetera, that one can use. I think the data really point to the fact that a combination of pharmacology and talk therapies are generally best. And there are a huge range of these things. I know many of you are in these professions, so we're not going to talk about that right now. There is a compound that's kind of interesting in the supplement space that isn't mecunopurine's L-Dopa. It's not L-tyrosine. That isn't promoting massive releases of dopamine or even dopamine alone, but a combination of dopamine and serotonin. And it's an intriguing molecule. It's sold over the counter. Again, you have to check with your healthcare provider before you would take anything or remove anything. That's very important. But it's phenylethylamine, or PEA. PEA, or beta-phenylethylamine, releases dopamine at low levels, but also serotonin at low levels. So it's kind of a cocktail of the motivation molecules as well as the quote unquote here and now molecules. And people's response to this varies widely, but many people report feeling heightened sense of mental acuity, well-being, etc. It is a bit of a stimulant, like anything that triggers activation of the dopamine and norepinephrine pathway. But it is an interesting supplement. So now let's talk about what is a dopamine schedule and how you can leverage this in order to have heightened levels of motivation, but not get so much dopamine that you're experiencing a crash afterwards, and also so that you can experience heightened pleasure from the various pursuits that you are engaged in life. And here's the key principle. Dopamine is very subjective, meaning you can either allow yourself to experience the pleasure of reaching a milestone, of achieving or some craving, or not. It's actually pretty powerful what one can do with the subjective system. In fact, I'm going to describe to you an experiment that highlights just how powerful the subjective readout or the subjective interpretation of a given experience really can be, even at the level of pharmacology. And the title of the experiment is Expectation for Stimulant Type Modifies Caffeine's Effects on Mood and Cognition. And this was done in college students. It's a fascinating study. What they did is they gave college students either placebo, essentially nothing, or 200 milligrams of caffeine. 200 milligrams of caffeine is about what's in a typical coffee, like a medium coffee that you would buy, a drip coffee. So they took 65 undergraduate students in college. They randomized them to either placebo or caffeine, and they told them that they were either getting caffeine or Adderall. Now, Adderall cognitively carries a very different expectation. College students know Adderall to be a much stronger stimulant than caffeine. They know it to create a sort of high. This is the way the students described it. And they thought that it would increase their level of focus and their ability to perform work. So what was really interesting is there was definitely an effect of placebo versus caffeine. That's not surprising, however, right? You take a placebo, you may or may not feel more alert. But you take 200 milligrams of caffeine, very likely you're going to feel very alert. But there was also an effect of whether or not the students thought they were getting caffeine or Adderall. The subjects receiving caffeine reported feeling more stimulated, anxious, and motivated than the subjects that received the placebo. Okay. But the ones that expected Adderall reported stronger amphetamine effects. They performed better on a working memory test. And in general, they had all the increased cognitive effects that would have been seen with Adderall, but they were only ingesting caffeine. So it led to heightened performance simply because the students thought they were getting Adderall. And I think this is very important because I think that it points to the fact that the top down, the kind of higher level cognitive processes are impacting even the most basic fundamental aspects of, say, dopamine release or our adrenaline release or epinephrine release in ways that can positively impact performance. In this case, it was a positive improvement in working memory and focus. So today we've talked a lot about the dopamine system and those kinds of schedules that will allow craving or addiction. But what's the schedule of dopamine that's going to allow you to maximize on your pursuit of pleasure and your elimination of pain? And we get the answer to that from our good friend gambling. The reason gambling works, the reason why people will throw their lives away, the reason why people go back again and again and again to places like Las Vegas and Atlantic City is because of the hope and anticipation. Those are cities and places built on dopamine. They are leveraging your dopamine system. And as a friend of mine who's a certified addiction treatment specialist tells me that, gambling addiction is a particularly sinister because the next time really could be the thing that changes everything. Unlike other addictions, the next time really could change everything. And that's embedded in the mind of the gambling addict. And rarely does it work out in favor of the well-being of the gambling addict and their family. However, the intermittent reinforcement schedule was discovered long ago by scientific researchers. So this is the slot machine that every once in a while gives you a win to keep you playing. This is the probability of winning on the craps table or the roulette table or at blackjack just often enough that you're willing to buy tickets, head out there, play again, go downstairs again from your room, even though you swore you were done for the night. Intermittent reinforcement is the most powerful form of dopamine reward schedule to keep you doing something. So we can export that. We can use it for good. If there's something that you're pursuing in life, whether or not it's an academic goal or a financial goal or a relationship goal, one of the things that you can do to ensure that you will remain on the path to that goal for a very long time and that you will continue to exceed your previous performance, as well as continue to enjoy the dopamine release that occurs when you hit the milestones that you want to achieve, is to occasionally remove reward subjectively. Let's say you set out a goal of I'm going to make this quantitative with respect to finances because it just is an easy description, but this could also be in sport, this could be in school, this could be in music, could be in anything, creative endeavors. But let's say you set out a certain financial goal, or let's say you want to get a certain number of followers on whatever social media platform. As you reach each one of those goals, you should know now that the amount of dopamine is not going to peak. It's actually going to diminish and make you crave more. The key to avoiding that crash, but to still keep it in healthy levels that will allow you to continue your pursuit, is as you are staircasing toward your goal, you actually want to blunt the reward response for some of those intermediate goals. Now, I'm not telling you shouldn't celebrate your wins, but I'm telling you not to celebrate all of them. Or as a good friend of mine who recently, fortunately for him, had a great financial success, he asked me and somebody else, a good friend of mine who's very tuned into dopamine reward schedules, understands how they work at a really deep level. And he said, I don't know what to do next. And we said, oh, well, that's simple. You should just give most of it away. And this wasn't a ploy to receive any of the money ourselves. This was really about reducing the impact of that reward. Now, hopefully giving him money away, if you already have enough of it, would be something that was rewarding in and of itself. But if you're a student who's pursuing goals in university, or you're an athlete who's pursuing goals, it actually makes sense from a rational perspective, once you understand these mechanisms, to hit a new high point of performance, or to get that A+, or for you, if it's an A-, et cetera, and to tell yourself, okay, that was good, but to actually actively blunt the reward, to not go and celebrate too intensely. Because in doing that, you keep your dopamine system in check, and you ensure that you're going to stay on the path of continued pursuit, not just for that thing, but for all things. Big increases in dopamine lead to big crashes in dopamine, and big increases in dopamine up the ante. So you can lift the what Las Vegas and Atlantic City and other gambling mechanisms and places have known for a long time. They lifted it from the scientists. You can now take it back and you can start to leverage that, and you just make it intermittent. You reward yourself not on a predictable schedule. So not every other time or every third time or every 10th time, but sometimes it's 3 in a row, then not at all for 10 days. So reward is important. Self-reward is critically important, but make sure that you're not doing it on such a predictable schedule that you burn out these dopamine circuits, or that you undercut your own ability to strive and achieve. Hopefully you now know far more about the dopamine system, reward, and motivation than you did at the beginning of this podcast. Hopefully you also understand the other side of dopamine and reward, which is pain and the balance of this pleasure-pain system, as well as the molecules that we call, or that were described in the Molecule of More book, I should say, as the here and now molecules, things like serotonin and the endocannabinoids. Finally, I want to thank you for your time and attention today. I hope you learned a lot, and that you learned a lot of possible tools that you could incorporate into your life as it relates to motivation and emotions. Thank you for your interest in science.